Hello, Professor. This is for question 5. This is the large rock that is sliding down a mountain. And the two setup questions that I picked was the velocity as the rock reaches the bottom and the rotational kinetic energy of the rock as it reaches the bottom of the mountain. And to start with this was my free body diagram of just understanding like what actually is going to happen. And when I was planning it out, there's no initial work energy. Those are my numbers, I'm sorry. Those are my numbers as well that I got from my phone number, but there was no initial work energy. There is potential, but no kinetic energy on the initial because it's not in movement. And then as it is moving towards the end, the final energy, there's no potential, but there is a kinetic final energy as it's hitting the bottom of the mountain. So once I established that the potential energy is equivalent to the initial potential energy is equivalent to the kinetic final, I separate the kinetic energy into transitional and rotational, which is pretty much like linear energy, which is the mass v squared, and this would be the moment of inertia rotational velocity squared. And this is the part that actually tripped me the most. It's this right here. There was a lot of different solutions for what is the moment of inertia for a solid sphere, but it turns out that some of them are for hollow spheres or smaller spheres, but this one seemed to be matching the most. And when I plugged that in, and then I started to solve for, or I just started to simplify things because like everything had mass, so I took out the mass, and then getting rid of the r squareds left me with this. Coming over here, there's more simplifications, and then primarily looking for the velocity, which when I solved down, I got 34.6 meters per second. And then from that velocity, I was able to turn back to the this part of the formula and actually just plug it in directly in order to find out how much joules of rotational kinetic energy there was. Right. That is what I got. And thank you very much, Professor.